Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will speak about nuclear physics. First, we started with atomic structure. The atom consists of nucleus surrounded by electrons. The nucleus consists of protons and neutrons. Protons and neutrons are known as nucleons. The proton has positive charge. This charge is equal to the electron charge, but its mass is equal to 1,832 times of the mass of the electron. A neutron is electrically neutral, whose mass is almost equal to the mass of protons. The element symbol can be written as follows, where X represents the chemical symbol for the element, A, which is called the mass number, which is equal to number of protons plus number of neutrons. Z is called Z number, which is equal to number of proton or electron. The neutron number is equal to A minus Z. The neutron number is equal to the mass number minus a Z number. Like here, Cl1735. It contains 17 protons and 35 minus 17, which is 18 neutrons. There are three kinds of atoms. The first one, isotopes, second, isobars, and the third is isotones. Isotopes are atoms of the same element, having the same atomic number Z but different in mass number A. For example, the isotopes of hydrogen atom, H11, H12, H13. The three atoms are hydrogen with the same Z number, but different mass number because the different number of neutrons in each one. The second type is isobars. Isobars are atoms of a different element have the same mass number, A, but different atomic number, Z. For example, oxygen 816 and nitrogen 716. The two atoms have the same mass number, but different Z number. The third one is isotones. Isotones are atoms of different elements, having different mass number and different Z number, but have the same number of neutrons, like carbon 614 and oxygen 816. All of them have the same number of neutrons. The normal radioactivity. The radioactive decay is a process by which an unstable atomic nucleus loses energy by radiation. The material containing unstable nuclei is considered radioactive. Three of most common types of decay are alpha, beta, and gamma decay. Alpha decay. The nucleus emitting an alpha particle lost 2 protons and 2 neutrons. So that the number decreased by 2 and the mass number decreased by 4. Like here in uranium, 92 to 138 converted to 2H, 90, 234, and alpha particle He24. The Z number decreased by 2 and the mass number decreased by 4. The properties of alpha particle. Alpha particle consists of 2 protons and 2 neutrons. Alpha particle was the first nuclear radiation to be discovered. Beta particle and gamma rays were identified soon after. Alpha particles are relatively slow and heavy compared with the other form of nuclear radiation. The particles travel at 5 to 7% of the speed of light. Alpha particles, because they are highly ionizing, are unable to penetrate very far through a matter and are brought to rest by a few centimeters of air and less than a tenth of a millimeter of biological tissue. Beta decay. The basis process in the beta decay converts a neutron into a proton and an electron. The neutron converts to proton and an electron. or the proton converted to neutron and give a positron. Here an example, C614 converted to N714 and giving E minus, which is electron, or beta minus. Neutron is converted to, nitrogen is converted to carbon and giving B positron, or beta, positive beta decay. Properties of beta particles. Beta particles are high-speed electrons or positrons that are ejected from a nucleus by some radioactive decay. Beta particles have a mass which is half of 1,000 of the mass of proton and carry either a single negative or positive charge. Their light mass means that they lose energy quickly through interaction with the matter and have very, very, very low ionizing power, much less than alpha particle. Gamma decay. In gamma decay, no change in atomic and mass number. Like here, the carbon atom is in high energy state. The carbon lost some of its energy in form of gamma rays. Gamma rays are electromagnetic wave of short wavelengths and high frequency. The wavelength ranges from 0.005 angstrom to 0.5 angstrom. Gamma rays travel with the velocity of light and are not charged particles like alpha or beta rays. Gamma rays produce a fluorescence effect of an photographic plate. Gamma rays ionized gas. They travel through. Gamma rays are highly penetrating ray, and they are even penetrative than the alpha and the beta particle. It can even pass through 30 centimeters thick of air. Thank you.